In this section, we will cover the fundamental of network address translation, also known as NAT. NAT, defined in RFC 1631, operates in layer 3 forwarding device to provide address simplification and conservation. The most common use of NAT is to connect networks using private RFC 1918 network addresses to the public internet. NAT translates the private address that are used in the internal network into public addresses that can be routed across the internet. As part of this functionality, you can configure NAT to use only one address for the entire network to the outside world. Using only one address effectively hide the internal network, thus provide additional security. Multiple devices can be configured to perform NAT services. Although firewalls are the most common, router and layer 3 switches are also capable of deploying this service. Cisco defined the following list of NAT terms. The inside local address is the IPv4 address that is assigned to the host on the inside network. The inside local host is likely to be one that falls within the RFC 1918 reserved private IPv4 address space. The inside global address is globally routable IPv4 address that represent one or more inside local IPv4 addresses to the outside world. The outside local address is the IPv4 address of an outside host as it appears on the inside network, not necessarily a public address. The outside local address is allocated from a routable address space. And finally, the outside global address is the IPv4 address that is assigned to a host on the outside network by the host owner. The outside global address is allocated from a global routable address or network space. In this example, the two inside hosts are each allocated a local IP address 10.0.0.1 is assigned 209.165.201.10, whereas any outbound traffic from 10.0.0.2 will be assigned to 209.165.201.111. The inside local address is likely to be one that falls within the RFC 1918 reserved private IPv4 address space. That reserved address space consists of 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. These addresses are not routable on the internet. This figure illustrates an ASA that is translating source address as the packet is forwarding from the inside to the outside and reversing that translation on the reply that returns. The steps are taken are as follows. Host 10.10.10.11 sends a packet to host B very clearly. The ASA receives the packet and check its NAT table. Okay, I will start from the beginning. This figure illustrates an ASA that is translating the source address as the packet is forwarded from the inside to the outside and reserve that translation on the reply that return. The steps that are taken are as follows. Host 10.10.10.11 sends a packet to host B. The ASA receives the packet and check its NAT table. It finds an entry to translate 10.10.10.11 to 203.0.113.2. If there was no entry in the table, the ASA would check the NAT rules to see if there was a rule specifying a dynamic translation. If there was such a rule, a new entry would be created. The ASA replaces inside local address of 10.10.10.111 with the inside global address of 203.0.113.2 and forward the packet. Host B received the packet with 203.0.113.2 as the source address. When host B replies, it specifies 203 192.0.113.2 as the destination address. When the ASA receives the reply packet and check is stable, it finds the entry that is associated with the inside global IPv4 address of 203.0.113.2. The ASA replaced the inside global address of 203.0.113.2 with the inside local address of 10.10.10.11 and forward the packet. One common variant of NAT is dynamic port address translation, also known as PAT. PAT is sometimes referred to as NAT overload or as high NAT. PAT allows you to translate multiple internal addresses into a few external addresses or even a single external address, essentially allowing the internal addresses to share one external address. PAT uses unique source port on the inside global IP version 4 address to distinguish between translation because the port number is enclosed into 16 bits. The total number of internal address that NAT can be translated into one external address is theoretically as many as 65,536. Some firewall would be also use a destination IP address and port number to distinguish between translation. In this case, the same source port number can be used multiple times, increasing the scalability even further. In either case, PAT allows for a high efficient use of the address space for outbound sessions. NAT requirement will vary from situation to situation. The Cisco SS support a variety of NAT deployment mode depending on the requirement. Here you can see 5 unique deployment of NAT: static, NAT maps an unregistered IPv version 4 address to a registered IPv version address 1-to-1. Static NAT is particularly useful when a device must be accessible from the outside of the network. For example, static NAT is used when a DMZ server needs to be continuously reachable by the same predictable translated addresses. Dynamic NAT maps an unregistered IPv4 address to a registered IPv4 address from a pool of registered IPv4 addresses. This is used for outbound client connection when you have fewer or outside global IP addresses than the inside localhost. When describing static PAT, it is best to imagine a network that has one single public IP address. This IP address must be used by the firewall that connects the network to the internet and must also be used as a PAT address for all outbound connections. If this network must also support a DMZ server, then static PAT can be used. For example, TCP port 680 may be reserved for PAT translation to the HTTP service on the DMZ service. Static PAT is sometimes called port forwarding. Finally, policy NAT use external criteria such as source address, destination address, and transport layer port to specify the translation. For example, traffic that is destined for particular network may be translated to a specific address reusing PAT, while traffic elsewhere is translated using a dynamic NAT tool. For further example on NAT and the configuration option, refer to some internet or description of this video.